NASA scientists detect an interstellar comet behaving strangely. Its path shifting, its core flaring with activity. Could be slowing down, preparing for something no comet has ever done. Unlike past flybys, this one shows new data. And the numbers don't lie. 3I/S is not just passing through. Something's changed. Arrival and discovery. The unexpected visitor. On the evening of July 1st, 2025, a small but vigilant telescope network in Hawaii quietly logged what would become the third interstellar object ever observed by humanity. It was Atlas, the asteroid terrestrial impact last alert system, that first noticed the faint moving light traveling too fast and on too strange a path to be native to our solar system. This wasn't just another comet. It was something else, something from beyond. By combing through archival sky images, astronomers soon recovered earlier snapshots, what they call precovery images. These helped trace the object's path backward across the sky, confirming it had been inbound for decades, undetected until it crossed the outer edge of the planetary zone. The object was named 3I/, the third confirmed interstellar object after Oumuamua in 2017 and 2I/Borisov in 2019. The I stands for interstellar, a rare designation, and Atlas credits the telescope that found it. Almost instantly, astronomers noted the hyperbolic trajectory, meaning it wasn't orbiting the sun. It was just passing through. Its speed, around 26 kilometers per second, was simply too high for the sun's gravity to trap it. This was a visitor, not a resident. Every new interstellar object is a message in a bottle, said one NASA planetary scientist. 3I/ATL is the third note we've found, and it's written in the language of the stars. The discovery sparked a surge of excitement and speculation. Forums buzzed, headlines exaggerated, and a few began to whisper. Was it heading toward Earth? But as we'll soon learn, the truth is more incredible than fear. The intrigue wasn't in where it was going, but in where it had come from. To understand just how alien this object really is, we need to look deeper, not at what it does, but at what it is and why it doesn't belong here at all. Interstellar identity. Why it's from beyond. Unlike most comets or asteroids tied to the sun by invisible gravitational threads, 3I/ entered our solar system like a rock skipping across a pond. Its eccentricity, a measure of how stretched an orbit is, was calculated to be well over 1, marking it as hyperbolic and definitively unbound. That number alone told astronomers this was no ordinary comet. It wasn't from here. Even more startling was its velocity. 3I/ATLAS hurtled through space at 26 to 30 kilometers per second, a pace twice as fast as the average solar system object. Such speed doesn't just appear. It's a legacy of gravitational ejections likely slingshot out of a distant star system after a cosmic collision or near miss with a giant planet. Now it had traveled light years to reach us. Trajectory mapping pointed back toward the constellation Sagittarius near the galactic bulge, a densely packed stellar region. Though not precise, this vector suggested it might have wandered the Milky Way for millions, perhaps billions of years, untouched before this fleeting encounter. Scientists drew comparisons with Oumuamua, the first known interstellar object, which was long, thin, and oddly fast spinning, and with 2I/Borisov, which behaved more like a traditional comet. 3I/ATLAS shared characteristics with both, but also defied easy classification. Its coma, a faint cloud of gas, formed far from the sun, an unusual trait. Was it volatile, rich, or was something even stranger? The deeper we look, said a lead astronomer at ESA, the more it tells us that other planetary systems might be more like ours than we thought. The question was no longer just about where it came from. It was what secrets it carried, locked in dust grains, frozen gases, and ancient ice. Was it material from the birth of another solar system? Or something older still, something primordial? As it came closer, scientists scrambled to measure it, to understand its mass, structure, and even its age. But what they found only made the mystery deeper. physical characteristics, and composition mysteries. When it comes to 3.2/Atlas, size was the first big question. Using the Hubble Space Telescope, NASA estimated an upper size limit of around 5.6 kilometers, about half the width of Manhattan. But the object wasn't particularly bright, and that dimness meant it could also be much smaller. Its dark, possibly carbon-rich surface reflected little light, making precise measurements difficult. Yet, something curious happened. Long before it neared the Sun, when it was still beyond the orbit of Jupiter, 3/ began to glow. It formed a faint coma, a halo of dust and gas typically seen in much closer active comets. This early outgassing suggested it was packed with volatile compounds, likely carbon dioxide and carbon monoxide, which sublimate at lower temperatures than water ice. More revealing was its tail behavior. Unlike most comets, whose tails stretch away from the Sun due to solar radiation pressure, 3A/A showed non-radial dust ejection, possibly due to its unique spin or the uneven sublimation of ancient ices. The tail was misaligned, pointing off angle, suggesting a chaotic surface, or perhaps active vents from buried volatiles releasing gas unevenly. Spectroscopic data from Earth and space-based telescopes detected traces of carbon monoxide, water vapor, and possibly methanol, but the ratios were unusual, not quite like solar system comets. That led to speculation. Could this be a comet that formed farther out than anything we've seen before? Or was it exposed to cosmic rays for millions of years between stars, altering its chemistry? One researcher called it a fossil of the galaxy, a phrase that stuck. Its composition, some argued, might date back to before the Sun was born, making it not just older than Earth, but potentially older than our entire solar system. And the implications of that were profound. This wasn't just a rock. It was a time capsule. With its alien chemistry and eerie brightness, scientists turned their eyes toward its path, its course through the solar system, and how close it might come to our own planet. Trajectory and approach, the path through our solar system. As of October 2025, 3I/ is sweeping through the inner solar system, approaching its perihelion, the point of closest distance to the Sun, estimated to occur on October 30th at about 1.4 astronomical units, or roughly 210 million kilometers. For comparison, Earth orbits at 1 astronomical unit. So, while it's getting close in cosmic terms, it's still far from any real threat. Its closest approach to Earth is projected at about 1.8 astronomical units, or 270 million kilometers, making it safely distant, more than 700 times farther than the Moon. Yet, due to the object's speed and brightness, it's still a prime target for observation. What made this pass even more exciting was its planned flybys of Mars and Jupiter. In early November, it would be near enough to Mars Express and ExoMars TGO, which could take advantage of their orbital instruments to scan its coma and dust trails. Later, in late December, the ESA's JUICE spacecraft would attempt distant imaging during its cruise phase beyond Jupiter's orbit. There was also a brief invisibility period in early October when 3I/ had passed behind the Sun from Earth's perspective. During this time, ground telescopes couldn't see it, and observations shifted to space-based platforms. Once it re-emerged, telescopes around the world relocked onto it. Despite the media noise, its exit path remained clear. By early 2026, March 8th will be well on its way out of the solar system forever, destined to drift across interstellar space once more. It's a cosmic tourist, said one ESA mission lead. It came in fast. It'll leave fast, and we'll never see it again. Before it goes, though, every major telescope on and off Earth is watching. And what they're seeing is rewriting what we thought we knew about deep space objects. Observation campaign. Eyes across the solar system. From a moment 3.2/Atlas was confirmed as interstellar, a global network of instruments sprang into coordinated action. On the ground, observatories like Atlas, Zwicky, Transient Facility, and the Very Large Telescope began routine tracking. But to capture a moving, dim object across vast distances, it took more than just Earth-based optics. Space telescopes joined the effort. Hubble captured high-resolution images to help constrain the comet's size and structure, providing the earliest clues that it was likely under 6 kilometers wide. The James Webb Space Telescope, operating in infrared, scanned for molecular signatures, especially gases like carbon dioxide, methane, and formaldehyde, which indicated how the comet was chemically aging as it approached the Sun. Meanwhile, planetary missions unexpectedly found themselves in the spotlight. Mars Express and ExoMars TGO, both orbiting Mars, were retasked to gather data during March 8th's flyby in November 2025. It wouldn't be close, but their spectrometers could still analyze the distant coma, offering a unique view from a different vantage point. The ESA's JUICE mission, though still en route to Jupiter, planned a series of long-range observations in December, turning its navigation and science cameras toward the comet. Even from millions of kilometers away, JUICE could gather valuable light curves, tracing changes in brightness and tail formation as 3/ left the inner solar system. But all this coordination wasn't easy. Tracking a fast-moving object with uncertain brightness required constant adjustment. Observatories had to time-share, dodge moonlight, and calibrate for light pollution, weather, and even spacecraft orientation constraints. "Interstellar objects don't wait for good weather," joked a mission planner at the European Southern Observatory. "They pass by once, and that's it." Despite the obstacles, the data volume was enormous. And the real challenge would come after the comet was gone, when scientists would spend years analyzing what this visitor left behind in their images and spectra. But not everyone was focused on the science. In the shadows of data and discovery, wilder theories took root, and some questioned whether 3/A might be something more than just ice and dust. Wild speculations versus scientific caution.